In this video, we're going to look at the first type of factoring, GCF, greatest common factor. First of all, we're going to look at the motivation of this method. We need to know that factoring is reversing multiplication. So we're going to start with the multiplication example. Let's say if we are going to multiply 3a times 2b plus 5c. So this is a multiplication question. We need to multiply 3a and 2b plus 5c in the parentheses. So the parentheses indicate that we have to multiply 3a with both of them, 2b, 3a times 2b, and then we need to multiply 3a and 5c. This rule is called distribution, this distributive law. So we can do that. Say we do 3a times 2b plus 3a times 5c. And next we're going to multiply then the number 3 times 2 is 6, a times b is ab, plus 3 times 5, 15, a times c is ac. So that is the answer. If we have a question, that's called a multiply. Now, the factoring question will be reversing the steps we had. So if we are given a question, factor 6ab plus 15ac, what we need to do is we need to write this as something times something. What times what is going to be equal to 6ab plus 15ac. We did this kind of question for numbers. For example, if we are asked to factor 6, and we know it's 2 times 3. So with numbers, it's very easy to see one number times one number will give us a 6. But with numbers and variables or letters combined, it's not as easy to do. We may not be able to see it that quickly. But the idea is the same. We need to break down 6ab plus 15ac as something times something. So what times what is going to be equal to that? Okay, so we can go back to look at the multiplication question to get some idea to help us do factoring, because again, factoring is reversing multiplication. And notice that the answer 6ab, where did this come from? It comes from multiplying 3a with 2b, and this 15ac comes from multiplying 3a and 5c. So now when we go back, if we go back, reverse to that previous step, we need to be able to get 3a out from both. So there's a 3a that is multiplied into to get 6ab and 15ac. So the first thing is to find that 3a and separate from the ones we have, 6ab and 15ac. So let's look at 6ab and 15ac. How do we find the 3a separated? How do we know 3a is in both of them? So that goes back to the idea of GCF, which is called greatest common factor. So the way we do that will be very similar to finding the GCF of numbers. So first of all, we can let's put it down here, how to find the GCF. We can break down 6ab. So that's the first term, 6ab. We can break it down as a product of numbers and variables. So we know 6 we can break down as 2 times 3. A times b will just be a times b. And then we break down 15ac. 15ac. 15 is 3 times 5. So we're going to line up the same number 3, create a new column for 5 because there's not a column. I want to line up the same numbers. And then break down A, which we can't. So let's line up A with the one A we have. And C, we don't have a C column yet. Let's create a new column for C. So now the GCF will be the common ones, which is, or in other words, which is contained in both of them. So as we can see, we found a 3, we have found a A. Bring them down, that gives us 3 times A. That would be the GCF, and which is the one we multiplied into two terms. So that's the first step, to look for GCF, and that is why this type is called GCF. And because 3A is the greatest common factor of 6AB and 15AC. Actually, we have quicker ways. If you understand the process, we don't really have to break down, and we can find the common ones, the GCF, quickly. So for example, how do we find this number 3? So 3 is the GCF of 6 and 15. Again, remember, GCF is a number that goes into both numbers. And when you look at the 6 and the 15, you may be able to see that 3 is the greatest common factor. If you cannot see it, then you can still break down like I did. Okay, so that's the first step. Found the GCF. So to do this type, step 1, found the GCF. So for the numbers, you will do the same as before. For the variables, it's actually very easy. You look at A, well, they both have A. So A is the common factor, but they don't have a B or C in common. So the GCF would just be 3A. So that's the first step. So after I found the first, found the GCF, so I put the GCF in here, that would be 3A right here. And next we're going to find out, okay, 3A times what? So we need to find the other two terms, 2B and 5C. And notice that factoring is reversing multiplication. So a simple question, suppose we don't know what this number is and try to figure out. So if I ask you 6 is equal to 2 times which number? And we may be able to see, oh, well, I just know it's 3, but actually you could do division to get that number, because 6 divided by 2 is equal to 3. That tells us that number is 3. So the same thing, if I give you a very big number, say 393 equals 3 times one number, and you won't be able to see just like 2 times 3 equals 6. But you can, how do you figure out this number? You can take 393 divided by 3. And you will get 3 divided by 3 is 1, and 9 divided by 3 is 3, and 3 divided by 3 is 1. And so 393 is equal to 3 times 131. So that's how you found out the other missing one. The idea is very similar to this. Just like, say, okay, I need to find out 3 times which number is equal to 393. I take 393 divided by 3. That will give me the other one. So here I already know 3A goes into this left-hand side. I need to find out 3A times what gives me that. So if you think of this whole thing as 393 and the 3A's as number 3, and how do you find out the other one? You take this whole thing divided by 3. So we're going to do the same thing. We take this whole expression divided by 3A, which corresponds to 3, and 6AB plus 15AC corresponds to 393. So we're going to do division. And it's very easy to remember why we're doing division, because factoring is reversing multiplication. So if you reverse multiplication, you're going to have to do division. All right, so let's do that. We're going to take 6AB. I'm just going to write it up here. So take 6AB divided by 3A. And I'm going to take 15AC divided by 3A. That will give me what I need. So let's do the first one. 6AB divided by 3A. 6 divided by 3. That gives us a 2. A divided by A, they cancel. And B will just be B there. And next, to move on, there's a plus sign. So we put a plus sign there. And 15 divided by 3, that gives me a 5. A divided by A, they cancel, and there's a C left. So that's how we go back to find 2B and 5C, which is what's given right here. So we found out if I'm given 6AB plus 15AC, and that can be obtained by multiplying 3A and 2B plus 5C. Alright, so let's look at another example. Suppose we're given, this would be example 1, now example 2. Let's make, we would put more variables and exponents in here. So let's say we have 2 a squared b plus 6 a cubed b. Okay, so the idea is the steps we already know. Oh, I didn't finish the steps here. Let's put step 2 here. We're going to divide the algebraic expression, whatever given, divide the given by the GCF. That's the second step. Okay, so let's go ahead and do that. We have first step to find the GCF. So this time can be a little quicker. So we have 2 and 6, and we know 2 goes into both goes 2 and 6. So GCF for the number will be 2. Now let's look at the variables. A squared and A cubed. What do they have in common? Apparently, if you break down A squared, they have it's AN times A. If you break down A cubed, you have A times A times A. Apparently, they have 2 A's in common. So the tip is, if you have A squared and A cubed, you always take the lower one. If you have 3, you take the lowest. So the greatest common factor for A squared and A cubed will be the lower exponent, A squared. So similarly, look at A, B and B. Well, they're the same, of course, just take the B. B and B, they both have B in common. So this is the GCF that we found. And step 2, we divide the given by the GCF. So we're going to because we need to find out 2A squared B times what is going to give us 2A squared B plus 6A cubed B. We're going to take both of them, divide by 2A squared B. So let's do that. I'm going to use a different color here and just go ahead and do it here. Divide by 2A squared B, divide by 2A squared B. Now notice that 2 divided by 2, they cancel. So we do divide by 2, they cancel. But you should know they cancel. 2 divided by 2 actually equals 1. When they cancel, you don't get 0, you get 1. A squared divided by A squared, they cancel. B squared divided by B squared, they cancel. Again, when we say they cancel, we actually get 1. So we should get 1 times 1 times 1. But we know 1 times 1 times 1 will still be 1. That's why you just put a 1 there. Alright, now next, divide the next part. Plus 6 divided by 2, that's a 3. A cubed divided by A squared. By the formula we learned before, we subtract the exponent. So we get an A, and B divided by B, they cancel. And we can double check our answer by multiplying back. So if you distribute 2A squared B times 1, you get 2A squared B. Distribute 2A squared B to 3A, you will get 2 times 3 is 6. A squared times A is A cubed. And B times nothing is B. And that's how we check to make sure our factoring is correct. But the checking part, you can do it on your scratch paper. The answer for this type of question, factoring, will be something times something. So make sure factoring is reversing multiplication. So the answer should be something times something. So the ones I circled, they are the answer.